Hello everyone, this is part 2 of part 2 on the resultant of the general 3D force system. And there are 5 problems here, levels 11 to 15. So this is the continuation of part 1. A table exerts the 4 forces shown on the floor surface. Reduce the surface system to a force coupled system at point O. Show that R is perpendicular to MO. So this is it. Then first, let's have the resultant, which is pointing towards the negative z direction. So r is equal to negative of 200, negative 160, negative 160, negative 80 k. So r in vector form is negative 600 k newtons or downward, 600 newtons downward. For moment about OX, for MO, we have to evaluate MOX by right thumb rule, scalar approach. So your right thumb is here. The curling of your forefingers would be in this sense, positive moment. So therefore, because 200 and 160 produce movement which is opposite to the positive sense, so they are negative. Negative of quantity 200 negative 160 times zero point 0.6. So MOX is equal to negative 216 Newton meter. This 160 and 80 pass through x-axis, so that's why they produce no moment. MOY, this is the y-axis, positive y-axis. So the curling of your four fingers, if this is your right thumb, is positive moment would be in this sense. So again, 160 and 80 here will produce negative moment. So negative quantity 160, negative 80 times 0.9. That's MOY. Sorry, positive. The curling of four fingers, if this is your right thumb, would be in that sense. So the moment of 160 and 80 would be positive about MOY. So sorry, it's positive. That's the positive sense. This is your right thumb. These are your four fingers. So the sense of moment would be in that sense, same as 160 and 80. So quantity 160 plus 80 times 0.9. MOY therefore is 216 Newton meter. And because all forces are along z, so there's no moment about z. In vector form, MO is negative 216I plus 216J Newton meter. So to show that R is perpendicular to MO, then we must determine the angle between them by dotting R with MO. And obviously, that's the magnitude of MO, square root of 216 squared, 216 square. So MO is 216 square root of 2 Newton meter. Then R has a magnitude of 600. So R dot MO is obviously 0 because this is K, and MO will have negative 216I and 216J. There's no K there. So definitely the dot product is 0, and R is equal to R times magnitude of MO, cosine of the angle between them. Because this is 0 at the left, then inverse cosine of 0 is 90 degrees. So that's why the angle between R and MO is 90 degrees, which shows that they are perpendicular, or R is perpendicular to MO. So conclusion, R is perpendicular to MO. And the force is negative 600 newtons, and the moment in vector form is quantity negative 216I plus 216J Newton meter. The pulley wheels are subjected to the load shown. Determine the equivalent force coupled system at point O. So there's no Rx 0. Ry is 400 plus 600, so 1000. Rz is 200 plus 300, so 500 newtons. So R in vector form is 1000 J plus 500 K newtons. For moment about OX, this is your right thumb, so the positive curling would be in that sense. So 600 is positive, 600 times 0.18 meter, then minus 400 times 0.18. Then 200 is positive also, 200 times 0.24 minus 300 times 0.24. So MOX is quantity 600 minus 400 times 0.18 plus quantity 200 minus 300 times 0.24. So that's MOX. It is equal to 12 Newton meter. MOY, this 400 and 600 are parallel to Y, so they produce no moment. If this is your right thumb, then your four fingers, curling of your four fingers would be in that sense, which is opposite to the moment of 200 and 300 in that sense. So MOY therefore is negative quantity 200 plus 300 times 0.6 meter. So MOY is negative quantity 200 plus 300 times 0.6. So MOY is negative 300 Newton meter. Finally, MOZ, if this is your right thumb, the positive sense of moment would be in that sense. So these two are parallel, so no moment. So 400 and 600 have the same positive sense of moment about Z. So it is quantity 400 plus 600 times 1.2 meter positive. So it is equal to 1200 Newton meter. So in vector form, MO is 12 quantity 12I minus 300J plus 1200K Newton meter. So that's it. Determine the force couple system at O, which is equivalent to the two forces applied to the shaft AOB. Is R perpendicular to MO? So this is the figure. So we can solve this by vector approach, but I'll present the scalar approach because definitely you will like the scalar approach better than the vector approach. Unless otherwise, the situation is very challenging that we have to apply the vector approach. So let's resolve each force into components. This one is 600 cosine 30. 600 cosine 30 is 519.6 newtons. The vertical component along Y is upward 600 sine 30, so that's 300 newtons. Likewise, this component is 800 cosine 45, 565.7 newtons, then 800 sine 45 downward is the same, 565.7 newtons. So all the forces and components lie on the YZ plane, so there's no X. Rx is 0. Obviously, Ry is 300 minus 565.7. So Ry is negative 265.7 newtons. Then Rz, 519.6 plus 565.7. So the Z component of the single force is equal to 1085 newtons. Therefore, in vector form, R is negative 265.7 J plus 1085 K newtons. For moment about OX, it's 0 because the original forces act on the x-axis. So MOX is 0. MOY, if this is your right thumb, the positive sense of moment would be the curling of your four fingers, like that. So 519.6 is positive times 0.08, then minus 565.7 times 0.16 negative, because this 300 and 565.7 parallel to the y-axis, they produce no moment. So positive sense of moment, if this is your right thumb towards the positive y-axis, would be in that sense. So MOY is 519.6 times 0.08, then minus 565.7 times 0.16. MOY therefore is negative 48.94 Newton meter. MOZ, this is your right thumb, so the positive sense of moment would be that. And 300 is opposite. 565.7 is also opposite. These two are not involved. They are parallel to the z-axis. So negative 300 times 0.08 and negative 565.7 times 0.16. So MOZ is negative 114.5 Newton meter. In vector form, MO is negative 48.94 J, negative 114.5 K Newton meter. So if we dot R with MO, because we have J here, definitely the dot product is negative 265.7 times negative 48.94 plus 1085 times negative 114.5. If it is not 0, then R is not perpendicular to MO. So the angle between them is not 90. So since we can evaluate the dot product of R with MO, not 0, so therefore R is not perpendicular to MO. So that's it for this problem. Replace the two forces and single couple by an equivalent force couple system at point A. So here is the given figure. So let's apply scalar approach here, not by vector approach, because we can answer them by using the vector approach. The system is not so complicated. So let's resolve 40 kilonewtons into components along Y and along Z, because this force is on the YZ plane. So 40, the slope is 3 along Y, then 1 along Z, then square root of 10. So therefore, this component is 40 times 3 over square root of 10. 40 times 3 square root of 10 is 37.94, while the Z component towards the positive Z axis is 40 times 1 over square root of 10, and that is 12.65 kilonewtons. So Rx therefore is negative 20 only. Ry is, that's a positive Y, so negative 37.94. And Rz is positive 12.65 because it is towards the positive z-axis. So R in vector form, the force in this condition is negative 20I minus 37.94 J plus 12.65 K kilonewtons. Now that's the force at A. Now for the moment, let's evaluate MAX, MAY, and MAZ. So MAX is this axis here. So since the 40 kilonewton force passes through the x-axis through A, it produces no moment, and 20 is parallel to this 35. If this is your four fingers, same sense as 35, your right thumb will be pointing upward, which is opposite to the positive z-axis. Therefore, this 35 couple, kilonewton meter couple in vector form is negative 35 K kilonewton meter. So C sub 1 is negative 35 K kilonewton meter because your right thumb will be pointing up opposite to the positive z-axis. So MAX is 0 because this is along Z. MAY, so take note, this is point A, not this one. MAY, so positive y-axis is there. Your right thumb will be pointing in that direction. Then your four fingers will curl in this manner. So this is the positive sense of moment. So therefore 20 is positive. 20 times 1, that's 1. Then plus 12.65 MAY plus 12.65 times 2. So MAY is 20 times 1 plus 12.65 times 2. So MAY is equal to 45.2 kilonewton meter. MAZ, this is the z-axis, so your right thumb will be pointing here. So the positive sense of moment about AZ is in that sense. The curling of your forefingers would be in that sense because your right thumb would be here pointing downward. That's the Z, positive z-axis. So it is equal to negative 35 for C sub 1, then plus 37.94 times 2. Of course, MAZ 20 has no moment. It acts on the AZ axis. 12.65 is parallel to the z-axis, so they are not involved. So negative 35, this negative 35, then plus 37.94 times 2. So MAZ is equal to 40.88 kilonewton meter. So in vector form, moment about A is equal to 45.3 J plus 40.88 K kilonewton meter. So this is the force and that's the couple at A. Equivalent force and couple system at A. The horizontal top of a concrete column is subjected to the system of forces shown. Represent the resultant of all forces as a force R at point O and a couple M. Also specify the magnitudes of R and M. So here is the given figure. So solution Rx, this is the positive x-axis. So it is positive 1 plus 3. So positive 1 plus 3 is 4 kilonewtons. Ry is, this is the positive y direction. So 2 plus 4, 6 minus 3. So that's why it's 3. Then Rz is 2 minus 3, negative 1, minus 5, negative 6. So in vector form, the force R is quantity 4I plus 3J minus 6K kilonewtons. Then for moment, let's use scalar approach again by right thumb rule. MOX, this is your right thumb. So if that's the right thumb, the positive sense of moment about OX would be in that sense. So it is 2 times 0.8. Then these horizontal forces pass through X, so they produce no moment, as well as this one. And these 2, 1, and 3 are parallel, not involved. So only these vertical forces, but this one, 3 kilonewton, is on OX, so no moment. So it is positive 2 times 0.8 minus 5 times 0.4. 0.4 is 0.8 minus 0.4. So 2 times 0.8. By the way, the magnitude of R is square root of 4 square plus 3 square plus 6 square. Because it is stated there, we have to specify the magnitudes of R and M. So the magnitude of R is 7.810 kilonewtons. Again, MOX is 2 times 0.8, or MX is 2 times 0.8 minus 5 times 0.4. So it is equal to negative 0.4 kilonewton meter. MOY, this is your right thumb, so the positive sense of moment about OY is the curling of your forefingers. So it should be that way. So all forces here are not involved because they are either parallel to the OY axis or they act on the Y axis. This one also is parallel. This one passes through OY, same plane. So only this force will have moment about OY. And since the positive sense of moment is in that sense, and this is in the opposite sense, so MOY is negative 5 times 0.8. MY is negative 5 times 0.8. So MY is negative 4 kilonewton meter. Then finally, MOZ, this is your right thumb, the positive sense of moment would be in that sense. All vertical forces are not involved. This is not involved because it passes through OZ. So there are three forces that are involved. 1, 3, and the other 3. So since positive sense of moment is in that sense, so 3 times zero point 0.8 is positive, 3 times zero point 0.8 is positive, and minus 1 times zero point 0.8. So mz is 3 times zero point 0.8 positive plus 3 times zero point 0.8 positive, then minus 1 times zero point 0.8. So mz is equal to 4.0 kilonewton meter. In vector form, therefore, the couple is m quantity negative 0.4i minus 4j plus 4k kilonewton meter. And the magnitude of m is square root of 0.4 square plus 4 square plus 4 square. So m magnitude is 5.671 kilonewton meter. So that's it for this problem.